Okay, here's our last example. Since there's only one side, there isn't a more complicated side to start with. Some of you might look at this and go, oh, let's try to write this in terms of sine and cosine. So let's do that. Sine squared is already in terms of sine and cosine, so we're going to just leave the numerator. Tangent is sine of x over cosine of x times sine of x minus sine of x over cosine of x. This can be over 1 if we'd like. Okay. Numerator hasn't changed, sine squared of x minus 1. Sine times sine is sine squared of x over cosine of x minus sine of x over cosine of x. So we have on the numerator here sine squared of x minus 1, and in the denominator we have sine squared of x minus sine of x all over cosine of x. But dividing by a fraction means the same thing as multiplying by a reciprocal. So we do sine squared of x minus 1 over 1 times the reciprocal, which becomes cosine of x over sine squared of x minus sine of x. Now, we can't cancel here because these things are being subtracted, and that really doesn't get us anywhere. So remember I said sometimes the process you choose will take you in the wrong direction, and you have to be willing to start over again. So let's start over. The other option is, can I think of either rewriting this as a trig identity, or can I do any algebra here? Well, let's think about this. If I had this in terms of algebra, this would be y squared minus 1. And this would be tangent of x times sine x minus tangent of x. Well, I have a tangent of x in both of those. Could I factor both of those out? That leaves me with a y minus 1, or sine of x minus 1. Because if I divide tangent of x out of here, I'm left with the sine x. If I take tangent of x divided by tangent of x, I'm left with minus 1. Now, I'm still not super seeing anything real great, except for think back to algebra. This becomes y minus 1 over y plus 1 when we factor it. This is tangent of x. And this we can think of, remember, as y minus 1, because our sine is our y value in our unit circle. Well, these now cancel. And so I'm left with, in the numerator, sine of x plus 1. And in the denominator, I'm left with tangent of x. Now that may be as simplified as it gets, but let's see what happens here. If I take this tangent of x and I multiply it, or I rewrite it, excuse me. So we end up with sine of x plus 1 over sine of x times the cosine of x. But again, remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So I have sine of x plus 1 over 1 times the reciprocal of the denominator, which is cosine of x times sine of x. So this becomes sine of x plus 1 times the cosine of x over the sine of x. Now, I can't cancel those because of this plus 1 here. I could distribute through there. Let's see what happens when we do that. So I have sine of x times the cosine of x plus the cosine of x, because cosine of x times sine x, cosine of x times 1, all over the sine of x. Now remember, as a fraction, I can take it and I can split that into two parts. So this can then become sine x cosine of x over sine x plus cosine of x over sine x. These I can cancel. That leaves me with cosine of x. But what is cosine of x over sine x? That's cotangent of x. I believe that's as simplified as we are going to get. So we have this sine squared of x minus 1 over tangent of x times sine x minus tangent of x simplifies to cosine of x plus cotangent of x. Again, you have to be willing to retry, restart, see where you can get. We might have wanted to stop right here, but if there's something in terms of sine and cosine, could we rewrite that in terms of sine and cosine? Sometimes it won't get us anywhere. Is this more simplified than that? Somebody could make an argument that it's not, but since I don't have any fractions here, this seems to be the most simplified form. Keep these steps in mind as you're working through these problems today.